Okay, next question. We have 4 square root 2 plus 3 square root 8, all divided by 2 square root 3. Now, this is a little bit different to the last question because uh, we have a square root on the denominator and we have a whole number on the denominator, and these are being multiplied together. Now, this question, I want you to rationalize the denominator and then simplify your answer. So have a go at that. Pause the video, and in about 10 seconds, I'll come back. Okay, so to rationalize this denominator, we don't necessarily need to times it by the 2 and the square root 3. We only need to times it by the square root 3 because with multiplication and division, you can do it in any order. And so we can isolate the part that we want to effectively rationalize and just multiply it but with that. So doing square root 3 over square root 3. Again, this is equal to 1, so we're not changing the value, we're just changing the representation. Writing out the next line. Should look something like this. Now, I could combine these to 6, but for the time being, I'm just going to leave them separate. Now, if you happen to multiply through both the 2 and the square root 3 into this, you can do that. It's just it's unnecessary, and you're going to get larger values that you're then going to have to do extra steps to simplify again later. And with math, you want to minimize the number of steps that you do so that you have less of a chance of accidentally making a silly error by putting in a negative somewhere or writing down the wrong number and ending up with the wrong answer. Because if you've got the wrong answer, you're not going to get all the marks. Okay, so let's multiply through that square root 3 into the numerator. So we have 4, 2 by 3 under the square root plus 3, 3 by 8 all over 2 by 3. Now, as I'm looking at this question, there's nothing really I can pull out of this first term. This second term here on the numerator, I could probably pull something out of the 8. So that's going to be 2 by 4, and the 4 can get pulled out as a 2. So let's do that. I'll write it in 2 steps just to make it a little bit clearer. But because nothing can really get pulled out of this here, I'm probably just going to leave that as square root 6. So I'm pulling that 4 out and pulling it out as a 2. So I'm left with 3 by 2 in that square root symbol. And to save myself writing out another line, I'm actually going to replace this 4 as a 2 by 2. Now you can see that each term has a 2 in it. So we can divide out 2 from each term. So again, I'll just factorize the top so you can see what's happening. And at the same time, I have combined 3 by 2 to give me 6 here. So I've pulled this 2 out the front and I've pulled this 2 out the front. That is over 2 by 3. And now you can see that hopefully a little bit more clear that these twos are going to divide out now. And I have a common square root 6 left on the numerator. So I can pull that out and have it as 2 plus 3 square root 6. So that will simplify to 5 square root 6 on the top, all over 3. Okay, next question. Very similar to the last one's structure. I have a number and a square root on the denominator. So pause the video here, give it a go, and I'll come back in 10 seconds. Okay, hopefully you've given that a go now. So I'm going to actually do this question two ways. A way that is very common of an approach, and then a way that is a slightly different approach, but uses critical thinking of maths to come about this problem a lot faster. So in the first approach, I'm just going to do it the same as the same as the last question, because that is the rule that was taught. And we're just going to apply the rule that was taught. So let's label this one as let's just say this is the applied rules technique. So square root 3 over square root 3. So just because the 3 is under the square root, that's the only thing that we're multiplying it with. So we have square root 3, then in brackets 7 square root 12 minus 5 square root 6, all over 6 by 3. Okay, multiplying in that square root, or expanding those brackets, we have 7 square root 12 times by 3. Now, I'm actually going to write this in as 36, just because that is a complete square, minus 5, and then we have 3 by 6, but at the same time, I'm going to write 6 as 3 by 2. So this 3 is that one, and that 6 became the 3 by 2. All over 6 by 3. So square root of 36 is 6. So you have 7 times by 6 minus, now we have two lots of 3's here, so one of them is going to get pulled out. So 5 times by 3, square root 2, all over 6 by 3. Now, if we look at common features, so the aim of the game is to always simplify as you go. If you look for common features, you can say, okay, there's a 3 here, there's a 3 there, and that 6 can be broken up as a 3 by 2. So we would factorize 3 out of every term, and so our 3's divide out. And you're left with 7 times by 2, so 14, minus 5 square root 2, all over 6. And so that's even, odd. I can't see any common factors anymore. I'd say that's your final answer for that question. Now, let's go over a slightly different approach for this particular question. So using the critical thinking of math straight away, we can see that if the end goal is to rationalize this denominator, we could always have in the back of our mind, can I simplify any step before proceeding? Again, it's to minimize the number of things that you're having to rewrite every time. So you're minimizing that chance of writing something incorrect, going from one line to the next. So I see that it's a 3 that I'm trying to get rid of. 6 is already, that can be broken down into 3 times 2. 12 is 3 times 4. So Using some critical thinking, I could, instead of applying this rule, break this up as to 7 square root 4 by 3 minus 5 square root 3 by 2 all over 6 square root 3. So I could factorize out my 3's and then divide them out. And I'm left with 7 square root 4 minus 5 square root 2 all over 6. So my denominator is already rationalized. Now I can just simplify this question. 4 in the square root, it's perfect square, can get pulled out as 2. So 7 times 2 is 14. I have 14 minus 5 square root 2 all over 6. And so I have the same answer as what I did before. It's just the amount of working was much less because I applied critical thinking instead of just the generic rules that were taught. Okay, next question. What happens if you have square root 12 minus square root 7 all over square root 12 plus square root 7? So we have two surds on the denominator with an addition or subtraction between them. So that it's no longer multiplication, it's addition. What do you do to rationalize this denominator? So before we get to that answer, let's actually take a step back and look at some algebra. So there's 3 main equations that you should be memorizing in year 11 or have already memorized. So you have your a plus b squared. Now this expands into a plus b, a plus b. So you have an a squared, an AB, a second AB. So you have 2 lots of AB. And then you have a B squared. Another equation is A minus B squared. So expanding this. Again, you have an A squared. You have a negative AB, a second negative AB, so minus 2AB. Minus minus, so plus B squared. So when you have this form, you have a positive 2AB. When you have this form, you have a negative 2AB. Now, the third equation, the one that we want to use in this particular case, is A plus B, A minus B. When you have something like this, expanding it, you end up with A squared minus AB plus AB minus B squared. So those middle terms are going to cancel out, and you're just left with the first term squared minus the second term squared. Now, hopefully this looks similar. You would have seen it in completing the square back in year 10 content. So let's pretend that these are all square roots now. So if you have square root A plus square root B multiplied by square root A minus square root B, and you expand this out, well, we've already seen you get the first term squared. So you're going to get this square root A squared. And then you're going to get that second term squared as well with a negative before it. So negative second term, which is square root B squared. So hopefully you can see where this is going. You now have A minus B. So the squares and the square roots cancel each other out. You have an A minus B. So if you have something on the denominator that looks like this, you'll be multiplying it with its conjugate. So the symbol in between the two, instead of it being positive, you'll be multiplying it with a negative, or vice versa. So going back to this question here, when you have 12 plus 7, or square root 12 plus square root 7, we're going to multiply that on the top and the bottom by its conjugate so that we only have the two original terms, but each original term is now squared. So each original term has lost its square root symbol. So I'll rewrite the question down here. So square root 12 minus square root 7 over square root 12 plus square root 7. If we multiply this through with their conjugates, we get square root 12 minus square root 7 divided by square root 12 minus square root 7. Expanding this, well, we have the exact same thing on the numerator twice because this is going to be expanded into each term. So you have two items being expanded into each term. You could theoretically draw uh, parentheses around this, and you see that it's the exact same thing. So you could just write that as square root 12 minus square root 7 all squared on the numerator. And on the denominator, well, let's expand this out. So again, this could have brackets there. So you have square root 12 times square root 12. So we have 12 square root 12 times negative square root 7. So negative square root 12 by 7 plus square root 7 by 12. And then minus square root 7 by square root 7. So minus square root 7 squared, so 7. Because again, that minus is on the outside of both the square root and the squared. Now you've got a positive and a negative middle term, so they cancel each other out as we thought they should, because we're following this rule here. And we are left with square root 12 minus square root 7 squared all over 12 take 7. So 12 take 7 is 5. So I'll rewrite this on the next page. Now, if we expand out the top, what would you get? So have a quick think. It's not just going to be 12 take 7 because we have these two terms. This bracketed stuff is multiplied by the bracketed stuff. So remember, when you have something like this, you end up with a middle term as well. So we're going to end up with that first term squared and then take two lots of the both terms combined plus the last term squared. So to make it a little bit easier, instead of just jumping straight into what that expansion will be, I'll write it out just so it's a little bit clearer. So I'll go back to re-expanding it. So square root 12 minus square root 7, square root 12 minus square root 7. Hopefully by the end of year 11, or even before then, you're able to just look at something like this and expand it using that formula straight into the end expansion over 5. So square root 12 times square root 12 is 12. And square root 12 times by negative square root 7. So we have a negative square root 12 by 7. And then we have a negative square root 7 by 12. Again, because these are just multiplication, the order doesn't matter. 7 times 12 is the same as 12 times 7. And then we have negative 7 times negative 7. So we have a positive 7 all over 5. We have 12 plus 7. So we have 19 minus 2 lots of 12 by 7 because we have 1 lot, 2 lots. So 2 lots of 12 by 7 all over 5. Now 12 is 3 times 4. So again, instead of combining them into a larger number and then trying to figure out what factors or what complete squares can get pulled out, I just go, well, 12 is 3 times 4. So that 4 is going to get pulled out. So we have 19 minus 2. So 12 is 3 by 4. And then we still have that 7 there. So in this step, I'm pulling the 4 out. So the 4 comes out as a 2. And then simplifying, that becomes 4. 3 by 7 is 21, all over 5. And I can't see any other common factors here. So I think that would be your final answer for that question.